In this video, we will continue studying scientific notation. Scientific notation is a very specific notation and a way to write a number. We need to make sure that we only have one non-zero digit to the left of the decimal point. The rest of the digits will follow the decimal point, and then you will have times 10 to some power. I want you to notice the numbers on the left-hand side of this chart. They are in scientific notation. There is only one digit to the left of the decimal point, that is non-zero, and the rest of the digits follow the decimal point. And then we have times 10 to some number. On the right-hand side of this chart, these numbers are not in scientific notation. Notice in the first one, we have 59 before the decimal point. 59 is not a one-digit non-zero number, as well as 852 in the next example. That is not a one-digit non-zero number. In the third example here on the right-hand side, we see that we have a 0 to the left of the decimal point. That's not in scientific notation because we need to have either a 1 through 9 as the digit to the left of the decimal. That is the same reason why our last example is not in scientific notation. We are going to use the reverse operation when we convert from a decimal to scientific notation. We are going to find the first non-zero digit as we move from left to right, looking at the number, and put the decimal point to the right of that digit. Then we will multiply times 10 to some number. The number for the exponent will be determined by how many places we move the decimal point in order to get it into the place to the right of the first non-zero digit as we look at the number from left to right. The direction for which we move the decimal point will determine whether the exponent on the 10 is positive or negative. If the direction you are counting is to the right, the exponent is positive. If the direction you are counting is to the left, the exponent is negative. And then write the number in scientific notation format. Let's look at some examples. Our first non-zero digit as we look at this number from left to right is 1. So we want to put our decimal point to the right of the number 1. And then we will write the rest of the digits to the right of the decimal point. We do not need to write the rest of the zeros, for this will not change the value of the number 1.2. Then we need to figure out the power of 10 that we will multiply in order to get the original number back. This is a large number, so therefore it will have a positive exponent. We move the decimal point 1, 2, 3, 4 places to get it to be in between the 1 and the 2. So our exponent is going to be a positive 4. In this number, we want to put the decimal point after the 9, the first non-zero digit. Then we'll write the rest of the digits. We do not need to write the rest of the zeros because that will not change the value of 9.8. Then we need to figure out what our exponent needs to be. It is going to be a positive exponent because this is a very large number. We move the decimal point 1, 2, 3, 4, 5, 6 places. So our exponent on the 10 is a 6. Our next examples are very small decimal numbers. We want to put our decimal point after the first non-zero number as we move from left to right. So we will put it after the 4 and write the rest of the digits. Then we need to figure out our power that will be on the 10. We move the decimal place 1, 2, 3 places. This is a very, very small number, so our exponent will be negative. In our next example, our first non-zero digit is this 3. We're going to put the decimal point to the right of the number 3 and write the rest of the digits. Then we need to figure out our power for our 10. We move the decimal 1, 2, 3, 4, 5, 6 places. So our exponent will be 6, and it will be a negative 6 because we moved the decimal place to the right. And this represents a very small number. So we get 3.21 times 10 to the negative 6.